Today we're just going to talk a little about what makes it so special and how we do AI so well. To start off with, the Whisper that we're running on the NetInt server, the Quadra server, we're using 96 cores, so it's a lot of cores with a lot of performance to do to run the AI. We kind of call this GPU free since there's not a GPU running the actual AI. We are running it directly on the CPU. So how are we able to do this so well? So one is because of the large core count. The second reason is because we have what we call our Ampere AI or AI optimizer software package. What this is we've heavily optimized PyTorch, TensorFlow, and Onyx for our hardware and our silicon. So this sits behind the scenes. It's nothing for the customer to use. You don't see it at all. But behind it, what's doing it's doing the model optimization. It's doing a conversion on the fly for you, and it's mapping the actual instructions directly to the key parts of our silicon. What does it mean? It means without the software to the software, you're getting almost a 2 to 5x increase in performance using this AI frameworks. This is completely free to customers. It's available on GitHub. It's just basically PyTorch optimized for Ampere. That's what we're looking at here. So this is the key element. So lots of cores, optimization software allows us to have high performance. To show us an example, and this is basically the NetInt Quadra server here. They demoed it earlier, but we are able to support up to almost 30 channels simultaneously streams, taking in the, and I know Mark talked about this already, so I won't take too long about this, but taking in the audio and actually having the closed caption output. Now this could be multiple streams. This could actually do multiple languages support. This can do many different ways. We can configure it many different ways. But the key is we are doing this AI directly on CPU and having high performance results. Now, people always ask about, okay, how's the actual performance look here? I want to draw your attention to the chart on the right first. So this is actual server raw performance. And if you look at our CPU, the Ampere Ultra Max versus an Intel and AMD, you can see these over these various workloads, whether a DLRM, which is for recommender engines. So think of Netflix. Do you recommend this? Do you recommend that? You like that? BERT, which is natural language processing. Think of Siri, Alexa, those kinds of things. And Whisper, which is what we're using here, which is speech to text. And ResNet, which is computer vision. So you could see in all these workloads, whichever one we're looking at here, the Ampere Ultra actually outperforms the Intel and x86 architecture that's out there. So just pure raw performance, we accelerate, we run faster. On the right side, this is what people care about, is cost. What is the performance per dollar I spend? And now what we're doing is we're looking at running this on top of the cloud. Cloud costs are generally fixed, so it makes it a very truthful statement about what kind of performance we can see at the cloud layer. And if you start looking at these models here, we're actually comparing, in this case, we're actually comparing against an A10 GPU, an NVIDIA GPU, versus also Intel and an AWS's Graviton. You could see, like in DLRM, recommender, we do very well, especially compared to the x86 architecture. BERT, of course, Whisper, extremely well. And this is why NetInt chose to use the Ampere Ultra, because if you look at the Whisper numbers, we outperform the lowest cost, most performance for the lowest cost. And of course, ResNet, which is computer vision. And that's where the GPUs are on par with where we're at, but much faster than CPU. The key statement here to make it is around here is what Sean talked about earlier is why is it so high? Why are we so good at this? It's because of our efficiency. Because our CPUs burn less power, cloud providers can charge less for their instances. So you have high performance, low cost. That gives us great price to performance characteristics. And this is what really leads people to starting to move over their AI workloads directly to our CPUs.